So today I'm going to talk about what's called the total probability theorem. And first we need the idea of what's called a partition. Okay, so we have a sample space and a partition of a sample space S. First I'm going to draw a picture that makes this easier, and then we'll talk about the actual math. So here is a sample space, and I'm going to divvy this sample space up into several events. And together, the events make up the whole sample space, and they don't overlap. So saying that mathematically, partition of a sample space S is a set of events B1 through Bn such that the intersection of any two of these events is the empty set. They don't intersect. And number two is that the union of these sets is the whole sample space. Okay? And kind of following on from the axioms of probability we talked about, since these events are all non-intersecting, I could also say that the probability of this union by our rules is the sum of these probabilities. I don't know exactly what each of these numbers is, but I know when I add them up I have to get the whole sample space. So exactly one of these events has to have occurred. Okay, so what are we going to do with this partition? Now I'm going to consider some event A, this red event, okay? And I'm going to ask myself, what is the probability of A? Well, I could compute the probability of A by adding up the pieces where A intersects with these other events. So visually, I can immediately say that the, just over here. Immediately, I can immediately say that the probability of A is equal to what I get by adding up the little red parts. It's the probability of A intersected with each of the BIs. Okay? Just each of these red pieces. And a different way of saying that from what we talked about last time about conditional probability, remember that the probability of A given B is the probability of A intersect B over the probability of B. And so here I'm just going to move this around to say, well, that means that the probability of A intersecting these BIs is going to be the probability of A given BI times the probability of BI. And this is called the total probability theorem. Okay, so let me write this down on one single page so you have it as a single piece. Right, this says the probability of A is equal to the sum of probability of A given BI times each of these probabilities BI, where the B's are a partition. Okay, so why is this important? Basically, the idea is that it relates the probability of an event to a bunch of conditional probabilities on other events that may be like possible states of nature. Okay, so let me kind of give you an example of this, and we're going to work some more examples in a separate video. So let's suppose that I'm looking at email clients and I'm scanning them for pictures of cats. Okay, so let's say that I have possible email clients. Let's say I've got Apple, Microsoft, Yahoo, and Gmail. Okay, and let's suppose that at some point in time, the market share of each of these clients was as follows: 44% for Apple, 29% for Microsoft, 7% for Yahoo, and 12% for Google. And does that add up to everything? I guess I need to have an extra couple percentage, other, 8%. So now I've got these numbers add up to 100%, right? So now I want to ask, what's the probability of getting a cat picture going across the internet? Well, I'm going to say it's the probability of cat picture given the client times the probability of the client summed up over all the possible clients that I have. Okay, and so this is kind of like the market share of the client. So it's like the probability of the client, and then I have something like the probability of cat given client is a set of other numbers, right? So for example, let's suppose that 12% of Apple emails contain cats, and 19% of Microsoft emails, and since people on Yahoo are probably mailing cat pictures to each other all the time, some high probability there, 20% of Google emails and 14% of other emails, right? So I kind of know how much is happening on each client, and to get the total amount of probability for cat picture, I would sum up to say, okay, well, I have the probability of Apple is 0.44, and the probability of cat picture given Apple is 0.12. So this would be kind of like your typical total probability theorem type problem. And I can add all those numbers up, and it turns out to be about 0.19. Okay, so I've discovered the probability of this large event by decomposing it into the sum of all the possible probabilities of its pieces. And we're going to do more examples like this next time and in the following lecture after that. Okay.